pi over 16 is a very small value. Cosine of pi over 16 is very close to 1, right? Less than 1, but very close to 1. And so, yeah. So we get a lot of new exact values. Should we do product to sum? Because those also are based on the addition identities. Yes, we shall. That's the answer for that. So, think of product to sum. Okay, so product to sum. Formulas, I guess. Formulae, if you like. Clear the decks here. And yeah, so look at this over here. I've got sine of the sum and sine of the difference, and the difference is whether it's a plus or a minus here, right? So if I add the sine of the sum to the sine of the difference, these cosine sine terms are going to drop out. I'll be just left with twice these, right? So let's be sure to write that all out. So I got sine alpha plus beta. That's going to be sine alpha plus cosine alpha sine beta. And I'm going to add sine of alpha minus beta. And this is not hard to remember, right? So it's hard to remember the actual identities from scratch. I mean, I suppose if you're using them a lot, you'll remember them more. But if you ever forget them, just never forget. If I told you my 7-Eleven joke? Yeah, it's kind of like that.
Got it. Got it.
So, yeah. So add these up, and you get of alpha plus beta plus sine of alpha minus beta is equal to what? Well, these guys cancel out, right? When I add them up, they're opposites. These guys double up. And so I can solve for the product, right? So I want to say the product is equal to a sum. So the sine of alpha times the cosine of beta, that's a product of trig functions. And I can say that's 1/2 sine of alpha plus beta plus sine of alpha minus beta. I need to use parentheses here because I'm taking half of the sum, right? So there's an identity. So why would that ever be useful? Well, suppose alpha and beta are very close to the same thing. Then this is going to be very close to 0, which means, well, think of it this way. So you've got alpha is 101t and beta is 100t. Here I'm thinking of t as time, right? So when I say sine of alpha, that's going to be sine of 101t, and cosine of beta is going to be cosine of 100t. Okay, I'm not sure where I'm going with this. Plus, so there's going to be 1/2 times the sum is going to be 201t, right? So that'll be sine of 201t. And then this is going to be plus the sine of t. So what are we looking at here? This is a periodic oscillator with wavelength 2 pi this is pretty much the same wavelength, huh? So if I multiply those together, I get two terms, one with a wavelength which is pretty much twice these wavelengths, which are almost the same, plus something with a very short wavelength, relatively short, right, 2 pi. I mean relatively long. Yeah, 2 pi over 201. So this has a very short wavelength. This has a relatively long wavelength. And so, yeah, that doesn't really help us a lot here in understanding anything. Or maybe it does, I'm just not seeing it. But if we'll go the reverse direction, it will be more clear. Yeah, so there's, we can also do the difference of these, right? So what if I were to subtract instead of adding? Well, then these terms would cancel out, and these terms would double up, right? So you can say similarly, cosine alpha sine beta is going to be 1/2 this minus that, right? So that would be sine alpha plus beta minus sine alpha minus beta. So there's another product sum. Is it really just the same thing in a way? I mean, you got a cosine times a sine, right? So yeah, right. Yeah, we reverse the angles, and then you get a difference instead of a sum, huh? So the sine of the difference, right? So if you reverse the difference, that sort of brings it out, right? So if you swap alpha and beta, then you negate this difference, which would negate the sign because it's an odd function, and you get back to here. So you can get that just by looking at the odd behavior of sine. It's an odd function. So there's another one. How about the cosines? Well, we can do the same thing, right? So add the cosine of the sum to the cosine of the difference, and one of these terms will cancel out. Should we do that? I don't know. It's the same routine, so it's just kind of a lot of writing. You get the same kind of result, except, well, it's different. So, okay, let's say, so I've got cosine alpha plus beta. That's cosine alpha, cosine beta minus, right? Sine alpha, sine beta. And if I add to that cosine alpha minus beta, well, that's cosine alpha, cosine beta plus sine alpha, sine beta. And when I add on the left side, I get a sum, which is going to be cosine alpha plus beta plus cosine alpha minus beta. And that's equal to these guys canceling out, and these guys doubling up. So I get twice cosine alpha, cosine beta. And then I can solve for the product. So now instead of getting a product of sine with cosine or cosine with sine, I got a product of cosine with cosine. And that gives me something significantly different, which is 1/2 cosine alpha plus beta plus cosine alpha minus beta. Reversing, well, let's see, so, yeah, so if I, so if instead of adding the second to the first, I subtract the first from the second. I say that because I want to subtract a negative to get a positive, right? So if I subtract the first from the second, in other words, if I go cosine alpha minus beta, that's the second, and I subtract from that cosine alpha plus beta, I get this cosine terms cancel out and the sine terms double up, right? So I get 2 sine alpha cosine beta, which I can then solve, sine beta, right? And all this symmetry starts to swim around after a while. So bear with me. So we get the product sine alpha, sine beta is 1/2 the difference cosine alpha minus beta. And we're only halfway done. Why? Well, because there's the sum to product formulas, which we get from these pretty much directly. So let's do that. We'll have them all. Well, that would be optimistic. So what do we have? We have these two, and then we have these two. Okay, so these are the sort of the final results of this computation over here. Product to sum formulas. So now, if we say that, introduce a couple of new variables. U is equal to alpha plus beta, and V is equal to alpha minus beta. All right, so we're doing like a substitution here. Can we solve this system for alpha in terms of U and V? Yes, we can.